Welcome back to week 9, and we are going to continue and talk about some of the ways we use to date geologic events. There's two basic categories. There's relative dating and absolute dating. So in relative dating, what you use is basically different types of laws and principles that we'll talk about in this video to establish a chronology of events. So you're only able to organize events in order. You can't put an actual number date on it. So you might be able to say when an uplift of a mountain range happened, when sea level rose, and then maybe when a new species evolved and appeared in the geologic record. But you can't necessarily say the exact time, just the order, which one's the oldest, which one's the youngest. In absolute dating, this is where you can actually get a number date. So we can actually establish when these events occurred and how much time has elapsed between present day and when they actually happened. So we can use various techniques to calculate thousands, millions, or even billions of years ago, which is pretty amazing and pretty awesome. So some of the techniques are radiometric dating. We'll talk about that last. Counting tree rings, layers of ice drilled from glaciers, and sediment layers in ancient lakes. So some of the relative dating techniques involve some of these laws, rules, and principles. So these are the ones we're going to talk about in the next few slides. So one of them is called the principle of original horizontality, and this is referring to sedimentary rocks. So that means that all sedimentary rocks at their original depositional state, when they were first deposited, were pretty much horizontal or parallel to the Earth's surface. So when we see rocks that maybe have been tilted, that's a sign that something has changed. There's been another event to alter those rocks. So we know that all sedimentary rocks would have been originally horizontal when they were formed. There's another principle called principle of lateral continuity. Basically that means that at the time that a rock is being deposited, this rock unit or strata extended continuously in all directions until maybe the deposit thinned out at the edge of a basin or ended abruptly. Maybe there was a mountain in the way, the river didn't migrate far enough, or it changed into a different sediment type, like a river entering into a lake. It's going to deposit the coarser grain stuff first, and then it's going to slowly change as you move away from the mouth of that river from coarser grain to finer grain. You can think back to your extra credit assignment on your arid environments lab, where you looked at the alluvial fan and determined how things changed from the mouth of that river to the end of it. Another principle is that principle of superposition. So basically it says sedimentary layers are undisturbed. They're deposited in succession. So we're going to have the oldest stuff deposited first, and then each layer on top of that is getting progressively younger until you get to the top, which would be the youngest. We have some structures that are called geopetal structures that are actually helpful to tell a geologist which way is up or which way is the top of each rock unit, which can be helpful, especially if you're in a highly deformed area with lots of faults and folds. These structures can help you determine which way is up. So ripple marks, cross-bedding, tracks, and trails are very helpful units. Another principle called cross-cutting relationships. So basically this is an idea where you have a rock unit, any type of rock unit, sediment, whatever, that is being cut by something else. The thing that's cutting across is a younger event. So for instance, in this picture down here, this is an igneous intrusion. So we've got the darker purple areas. That's the original rock in this area. That's going to be the older rock. And then the lighter pink bands that you see are the younger unit that cut across or cut through that other purple rock unit. So in order for this rock to cut through, this purple unit had to be there first. Same thing with this fault. We've got a fault that cuts across these two layers. Well, these two layers had to be here first for this fault to actually develop in it. The next principle is that of included fragments. So what this says is the rocks that are stuck inside of the other rock unit are going to be the older of the two. So these fragments here had to be present in order for them to become stuck in this other younger unit that's surrounding them. And then a principle of biotic succession. Well, this is the idea of now, due to lots and lots of research and work done by paleontologists, we know approximately when different organisms and fossils occur in the geologic rock record. So we can say when we see a specific type of fossil, we can see specific ones in order. It's going to help us determine what order these rocks were deposited in. And here we got some various fossils for you to see, and that we'll look at in lab in a couple weeks. So on to unconformities. Unconformities are a break in the rock record. They represent a gap in time where we've had erosion occur or lack of deposition. Here's just a picture of an angular unconformity. We'll talk about that in a couple slides here. But here you can see basically these rocks get cut off at the very top, and then you see another rock deposited on top. So there was this break in time here is representing who knows how long. If you know the dates of the youngest rock in these tilted layers and this rock up top, then you can get an idea. So the types that we have are what are called, one's called non-conformity. So we've got an older igneous or metamorphic rock on the bottom that formed at some point, eroded away the surface, so you get this kind of wavy, uneven surface. And then we have layered sedimentary rocks that are deposited on top of that over time. So there was a significant period of time, a break between when these metamorphic rocks formed and when these younger sedimentary rocks formed. The next type is called an angular unconformity. So these sedimentary layers on the bottom, they're older. They're not horizontal anymore. They've been tilted. So we would have had these layers deposited horizontally in some kind of tectonic event tilting them, eroding down into them, and then another depositional environment where we had sedimentary rocks deposited on top. And then the last type of unconformity is called a disconformity, and these can be sometimes hard to spot because you have both of your sedimentary layers above and below this unconformity are both parallel to one another because we haven't had any tectonic shifts to help tilt or uplift any of these rock units. So maybe we had sea level fall, sea level rise to help change the environment. So this wavy line here is representing a break in time where either there was erosion or just no rocks were deposited. So those are some of the relative age dating techniques. So we'll come back and talk about numerical in the next video.